Alright, here's a chapter where we are now working on matrices, and we've already dealt with matrices a little bit this year as we were doing chi-squared testing, but in that it was really just a matter of sort of seeing what a matrix was and understanding the dimensions of it, and that's kind of where this chapter begins. It's just identifying what is a matrix. So it's just a rectangular, what we call an argument of numbers, and we have rows and columns, and so the rows are the ones that go from left to right. So you can see this one had 2 rows in it. So this would be the first row and this would be the second row. And then the columns are the ones that go up and down. And so this would be column 1, this would be column 2, and column 3. And so whenever we identify the dimensions of a matrix, we always do rows by columns. And so we would call this a 2 by 3 matrix. Each number within the matrix we call an element. So this one has 6 elements total. And again, you can see the dimensions were 2 by 3. What we're looking at in this first lesson is just a few basic operations that we can do with different matrices. As far as adding or subtracting them, you can only add or subtract a matrix or matrices if they have the same dimensions. And so I can do a 2 by 2 with another 2 by 2. I can also subtract a 2 by 2 with another 2 by 2. But again, that's only because they have the same dimensions. When we add or subtract, we are just combining their corresponding elements. In other words, if I wanted to add these 2 matrices together, the top left of this one would go with the top left of this one. And the top right number would add to the top right number. And so you can see how those work out over here. Right? If I add together their corresponding elements, same with subtraction, would work the same way. So let's do a couple here with some real numbers in it. You'll notice that in the directions of example 1 here, it does say perform if possible. And so as I look at part A right here, this is a 2 by 2 and this is a 2 by 1 matrix. And so because their dimensions are not the same, we just have to recognize that and just say it's not possible to subtract. But when you get to this one is now a 3 by 2 with another 3 by 2, and so these we can add. And so again, I'm just matching up their corresponding elements. So the top left plus the top left. So you can see over here how that worked out. And then we'll just simplify that, of course, as we go. When we're doing this in the assignments, I would not expect that people would write this step down. This is really what you should be doing in your head in order to get this answer. And so really we should be able to go straight from here to here as far as just like doing regular problems on these. But this is just kind of good for the notes so you can see where these numbers are coming from in case you look back on them. But again, just kind of going down the list, and you would just match up all their corresponding parts. So again, something in the bottom left would add with the bottom left, and that's where we're getting our bottom left number. Right? And so they stay in the same position as you go to write your answer. If you can imagine, it's kind of like if I were to pick up this matrix and set it on top of this one, this is what we would get. Right? And so that's what we're doing, is we just match up their corresponding elements. Again, same with subtraction. With this one, you do got to be careful if you have double negatives and things like that. You got to make sure that all those things get accounted for. One thing that you could do whenever it's subtraction, something you learned a long time ago back in algebra, would be to do what we call add the opposite. So I could change that to a plus, change that to a minus, a plus. Obviously that would still be 0, but you could add the opposite, and that helps take care of things like double negatives, just to make sure you don't miss those. But just like this one, we're going to match up the corresponding elements. And so I would do, again, -6 minus 3, and that goes in the top left. In the top right, we would do 2 minus 0, and that goes in the top right. And you just keep on going with that. So bottom left minus the bottom left, and that goes in the bottom left part of our answer. And so pretty basic with just adding and subtracting on those. A and B that you're seeing right here, this is just like distribution. The number on the outside is what they call a scalar, and this just would apply to every element in the matrix. And so it's just distribution. So I multiply my 3 times 0, 3 times 2, 3 times -7. So you can see how all that was written for you right here. So we're just distributing the 3, and we would get this as our answer. Notice, just like the ones up above, the dimensions do not change. This was a 2 by 3. Our answer is still a 2 by 3 matrix, so that should never change. Here's just a scalar of -2. Same deal. You would just distribute that to all 4 elements, and this would be the result. So let me take you to the second side of this. Up top, you're seeing some properties for what we're allowed to do. Nothing too surprising in here. If I were adding 3 matrices together, in addition, we all know that order doesn't matter. And so I could do the A plus B first and then add C, or I could do the B plus C first and then add in the A. The order doesn't matter when it comes to addition. We just saw this in the last problem. If I had a scalar right there, I'm allowed to distribute that scalar into all of my matrices. And so nothing too surprising in there. So here's one of the things that we're going to do in this first lesson is a word problem where we are using some of what we just looked at. So one of the benefits of a matrix would be to organize the information of a word problem into a matrix so that we could use it to solve the problem. So in this case, you see we have 2 different shelters, and we're going to analyze what's going on in April and then what's going on in May. So you're seeing all the information for what's happening within the shelters for the 2 months. And for this one, we were specifically being asked what is the average monthly adoption for a 2-month period. And so remember what finding an average looks like. It just means you're going to add up the parts and then divide by the number of terms. And so that's all we're doing on this one. So if I sort of take out all the words and just leave the numbers, here's what we have. So for April, shelter 1 had this many dogs and cats. Shelter 2 had this many dogs and cats. And so we organized that one for the month of April. Same information for the month of May. All right, just taken right out of those 4 numbers are just being placed right here into that matrix. Always important to title what's going on here. So you can see we have our first column was dogs and our second column was cats. Notice that whatever we did for the first matrix, we had to do the same thing for the second matrix. So if I want dogs and cats to be my 2 columns, I had to make the same thing in my second matrix so that all this will match up. So as I go to add these 2 together, because remember we're just finding an average, which means I want to add them together and then divide by 2. So as I add this matrix to this matrix and then divide everything by 2, here's what that would look like. All right, so just finding the average, and then as you simplify all that, here's what we got as the result. And so pretty simple. It's kind of nice and clean if we organize it within the matrix to find the average of those 2 shelters. So that's just one of the things we can do for them. And then here's the last thing we have to look at for lesson 1. And this is just solving an equation within a matrix. You can see a couple variables that came into this, and so we're just solving for x and y, and so really this is a matter of just pulling out the relevant information. As I look at these 2 matrices, if I want to solve for x, x is in the top left corner of the matrix, so really all I need to do for this is just pull out the information that is in the top left. So I'm looking at, and you'll see by the parentheses, right, that this 4 belongs to all of this. And so if I just focus in on the top left, I'm going to see 4 times 3x plus 1 equals -8. If I distribute that, I'm looking at 12x plus 4 equals -8. And that's where you're seeing this equation right here. So I distributed the 4. And again, I just separated out the elements that are in the top left position because that's where x is. And so if you just pull out that information, that's the first equation that you should be writing. This is a lot of extra work that I really would not expect you to do, but it just is supposed to help you see where this is coming from. But really, we can really just isolate the elements that are needed. This would be pretty easy to solve from here so that you could get your value for x. As we look at where y is sitting, I would do the same thing, and I would say since y is in the bottom right, I'm going to do 4 times 6 plus negative 2y, and I'm going to set all that equal to 0. And so if I distribute, I'm looking at 24 minus 8y equals 0, and that's where we're going to get the second equation, and then again we could solve from there to get our value for y. So pretty simple, just pull out what's needed, and so just where x and y are sitting. So same thing with the last one here. If we were to set up equations for this one, since x is sitting in the top right, I'm going to see this as negative 2 times, and then because of the parentheses, I need to see those parentheses are still there. So negative 2x minus negative 6, and then we're going to set that equal to 12, since that 12 is sitting in the top right position. And then that would be, again, a pretty simple solve from there. So just watch out for double negatives and the little things like that. If you're going to set up an equation for y, he's sitting in the bottom left, so I'm going to see as negative 2. So in the bottom left I have 1 minus negative 5y. And I'll close those parentheses, equals 8. And we have our second equation. If we solve those, we can get our values for x and y that we are solving for. So that's it for lesson 1.